Today I'm with my friend Andy from Gulp.
Hey,
Can you tell me a little bit about what Gulp does?
Gulp is an API that takes a look at your agent's prior interactions and then tries to figure out what it can improve on the second time the user asks your agent to do something similar.
And so how does that actually work? Where does the data actually come from?
Yeah, the data comes from actual interactions that your agent has in the real production setting. So we take a look at what the agent did well. Let's say it's gotten to the button correctly or clicked on the web page correctly, and then what it didn't do well. So if it looped a lot trying to figure out what was the correct answer or just outright forgot what the user asked for, we take a look at all of these conditions and then we generate recommendations on how the agent can improve. So next time when a user asks a similar prompt, we will then proxy that, take over it, and rewrite it to be more detailed and more directed to make sure that the agent knows exactly what the user wants.
So in this case, it's actually changing the prompt.
Yeah. So we are a proxy layer directly on top of your inputs. We realize that there's a lot of fancy infrastructure around agents when it comes to like RAG retrieval or knowledge stores. But when the user is just inputting the prompt to the agent, not much happens, right? And then we think that bad input equals bad output.
Why wouldn't RAG or just some kind of agent memory do what Gulp is trying to do?
On a memory solution, there's a really big problem with noise in a sense that every time your memory is trying to recall anything relevant, it's actually going to give you anything that's remotely even similar. If you search a RAG solution for red Nike shoes, for example, it might tell you about how to return them, how to buy them, or just what they are, but you really only care about like how to buy them in one specific case, right? And then with all this pollutant data, your agent actually deteriorates because it's unable to figure out what data is actually important and what data is noise. So what we do on the input side is we have a recommendation system that ranks the most relevant scenarios and rewrites the prompt directly so to ensure that the noise problem wouldn't affect your agent performance.
How does this tie into, if I'm building an agent, I'll often build evals off this. And so do you see that this typically helps people improve their eval scores over time? Or how do you actually work with people that are trying to use evals with agents they're building?
One eval that we've done internally is the Web Arena benchmark. Right now, I think state of the art is Operator at about 60% accuracy. So what we've done is we integrated the Gulp API into GPT-4o Mini, a very small and very efficient model. And then in our testing, we found that running all of the tests from the first, we were able to get almost 60% of a performance improvement beyond the normal GPT-4o.
Very cool. Thanks, Andy.
Yeah, no problem.